Welcome. I want to go over what will be your last lab. It's going to be a DIY, and hopefully you have a little bit of fun doing it. First thing I want to do is show you a YouTube video of the fountain in the McNamara terminal of the Detroit airport. It's one of the coolest fountains I've ever seen. And here there's a bunch of water jets. Most of them are aiming at one target, and most of them are hitting pretty close. It's cool. I think it's cool. Take a watch. Did you notice how most of them were aimed pretty well and hitting at the same target? Well, let's take a look at that. Up here, we have just a diagram of the trajectory. I want you to take a photograph of a trajectory of some fountain. You can make a fountain with a garden hose and nozzle. But what I want you to do is inside that, you're going to be far enough back, get the camera so that it's located right below the apex right there and right about at the level of the nozzle, if you can. But move far enough back so that we don't have much distortion, and put some sort of measuring device. That can be a tape measure, a meter stick, or anything that we can use to measure distances. I want to measure distances on here. So take that photograph, and this yellow curve or red curve will be the trajectory. And we can measure two things on here: the initial angle and Y max. I want you to do that in Photoshop, but show us what the initial angle is. And I also want you to estimate the uncertainty in that, because I could put a protractor on here and I could read it. Well, it could be anywhere, let's say from 43 degrees to 47 degrees. So I'd say 45 degrees plus or minus 2 degrees. You determine what these are, but be reasonable what these uncertainties are. But the experimenter is in the best position to estimate reasonable uncertainties. So we'll get the initial angle and the uncertainty of that initial angle. There's no one right answer on that, but there's reasonable and unreasonable values. Same thing, once you get Y max, the apex of this. And in this case, I just said, let's pretend like we measured it as 90 centimeters, but I was a little bit uncertain in that, plus or minus 1 centimeter. Again, you as the experimenter are in the best position to get the best estimate for your uncertainties. So two measurements: initial angle and Y max. And what I want to do with that, and I'll show you or guide you as to how to do that, we're gonna set up an equation where the initial speed is a function. We can get that as a function of this angle and Y max. Now, think about that intuitively. We should be able to do that. Let's say I have a nozzle here and it's squirting on this trajectory. If I speed up the velocity, it's going to overshoot this. Or if I slow it down, it will undershoot it. But there's only one velocity given an angle. There's only one velocity that will go through that have that one Y max. Similarly, if I have a Y max here, there's only one angle that will go through that, or that will have that Y max, rather. Anyway, we can get the initial speed is equal to a function of the two things that we can measure off of that photograph. We can't measure the initial speed, but we can measure the initial angle, and we can measure Y max. So I want to get an equation. Initial speed is this function of initial angle and Y max. And then I want to get the propagation of uncertainty. Well, I had an uncertainty of 2 degrees here and 1 centimeter there. Well, what's that going to be? What will that result in an uncertainty in our speed? So our goal here is to estimate what the speed is. And what's the uncertainty in our estimate of the speed? Just with these 2 pieces of information, what's the initial angle and its uncertainty, and what's the initial y max and what's its uncertainty? Well, let's look at how we would do that. Incidentally, this uncertainty analysis here is Klein-McClintock, Klein with a K, K-L-I-N-E, McClintock. You want to look that up on Wikipedia or whatever. Let's take a look at how we would solve for that then. Let's see. Okay, so this is just the handout. And we have, you learned in physics that for a trajectory like this, like if you throw a rock or something like that, it'll have a parabolic trajectory profile. Y at x equals ax squared plus bx plus c. This is just from 10th grade or so, parabola. Well, let's see, how do we derive that? I'll let you do the work, but I'm going to give you that equation. Y is equal to tangent of theta times x minus g over 2 times the initial velocity cosine squared, initial angle x squared. Well, notice that this only has 2 terms here. It has the x term and the x squared term. That's because if we take the nozzle as the origin, when y is equal to 0 and x is equal to 0, we're going to take that as the origin point. Then if x equals 0, y can only equal 0 if c equals 0. So c goes to 0, and we just have to find what b is and what a is. And let's see, here we have b is just tangent of theta. That's the initial angle, tangent of the initial angle. And minus g is gravitational constant, 2v squared, cosine squared, theta naught. Okay, so we have this equation. Well, I wanted you to get it as V0. That is, we want to find what V0 is in terms of theta naught and y max. Well, how are we going to do that? Well, first thing we'll do is we'll remember y max occurs when the derivative of this equation with respect to x is 0. So let's take the derivative of this equation and set it equal to 0. Derivative with respect to x. That'll take this out. That'll change this from x squared to 2x. And so these will cancel. And we can get an equation which will allow us to find the location of y max. That is, what's the x value when y max is? We'll plug it back into this equation and we'll solve for y max in terms of y max, in terms of initial angle, and in terms of initial speed. Because we know the x, we can find the x value at which this occurs. So we can get then this equation. We can get this equation. Initial speed is equal to a function of the initial angle and the initial, or y max rather. Those are the 2 things that we're going to measure. Okay, what am I going to be expecting from you as far as a write-up goes? Okay, title page, team names and level of effort. You know all about that. Introduction, explain what you're doing and why. What you're doing, you're trying to estimate the initial velocity of the water in a fountain, knowing 2 things. the maximum height that the fountain water goes to, the jet of water goes to, and the initial angle and the uncertainties of that measurement. So what we're trying to do is get initial velocity as a function of the two things that we measure. We're going to measure Y max and initial angle. Okay, the procedure, I want you to describe that in a way so that any engineering student can repeat what you did. I want you to include a photograph. I said photographs, but that could be a single photograph of your fountain where you show on that photograph your angle. You use Photoshop for that, your angle and your Y max and your uncertainty in angle and Y max. So show that on your photograph. And I want you to get this as precise as reasonable. It's going to be real hard to get a precise value. By precise, I mean small value on your uncertainty and angle and small value and uncertainty and Y max. That's going to be hard to do if you just get some little teeny trajectory like a drinking fountain or something, because it's going to be real hard to measure these accurately relative to the size of your trajectory. But do the best you can on that. And then I want you to derive all of these equations. I gave you the first equation up here. I want you to derive that just from physics will help you do that. Right? Or dynamics will help you do that. Let's see. So I want a derivation of that. All of these are to be typed. And then once you get this equation, I want you to get the initial speed in terms of these two. In terms of initial angle and Y max. These are the two things that we're going to measure. And I want to be able to estimate the initial velocity in terms of angle, initial angle, and Y max. And I want a derivation of this. And I showed you that on the whiteboard, but I didn't show you what the function was, but I showed you how to do that. Anyway, that's your first or your last lab that you're going to have to do. I hope you have fun at it. It can be fun, but it's going to be some thinking too. Wish you well, and I'm ending that. We will be meeting Monday for lab. We'll see you.